Hey, welcome back, guys. This is Professor Roldan with Explorations in Math. This is section 4.5, and this is our last unit. And so this is called Early Computational Methods. Okay, guys, so you know that we multiply a certain way. You've been taught in grade school. So, for example, 23 times 13. Okay. So this is called an algorithm, the way we do it. And this is not always how it was done throughout history. So this would be called the modern multiplication. And we can just add to that algorithm. Because the algorithm is basically the process in which you get this done. And so in this section, we're going to look at different ways of doing this. So let's just review the way we do this. So the ones place is going to be multiplied times the ones place and also the tens place. So that's 3 times 3 is 9, and 3 times 2 is 6. So basically we just did 23 times 3. And then this 1 in the second place value, that is the tens place. So that 1 is going to be multiplied by the 23 as well. But this 1 is actually a 10 because a 1 in the second place is a 10. So this is why we put a 0 here. And 1 times 3 is 3. And 1 times 2 is 2. And then basically the algorithm says go ahead and add up the place values. So we got the ones place, tens place. Okay? So let's take a look at other ways of doing the same thing. Okay? And before we do that, I just want to read a couple things, a couple highlights from the top. And that is, even the word algorithm comes from one of the greatest Arab mathematicians, Khwarizmi, okay, from the 800s to 847, okay, which we also get the word algebra. Okay, so the al, all right, and algorithm and algebra. Okay, so that's something just to remember. Remember that our system is Hindu Arabic. And so they do have a great influence in our math, our modern math. Okay, so there's definitely ways people did this. 23 times 13 using sticks, pebbles, tables, abacus, and a lot of them was complex, like we're about to see. Okay, so the great thing is that this Hindu Arabic numbers that came in replaced the widely known Roman numerals. Okay, so we already see how awkward those numbers are, and imagine trying to do multiplication with that. So let's go ahead and see what are the more ancient ways of multiplying numbers in the Hindu Arabic system. Okay, so the first process is called duplication and mediation. And duplication means double. It's a doubling. And really that just means to multiply it by 2. Okay? And mediation, okay, means having a number, and this just means divide by 2. Okay, to cut something in half or to divide it in half is to just divide it by 2. So let's take a look at the process for doing duplication and mediation. Okay, so number one, you want to divide the left side by 2 and drop any decimals. Okay, what do I mean by left side? So if you look at the bottom, we have a left and a right. Okay, we're about to do this in a minute. Okay, so the same numbers we just did in modern multiplication, we're going to do using duplication and mediation. So that's step one. Okay, step two is to multiply the right side by 2. Okay, so on one side you're going to be dividing on the left, and on the right you're going to be multiplying. And we're going to continue this process until the left side decreases to 1. Once you get to that 1, that's when you stop. Okay? Stop the process when the left side you divide by 2 over and over again, leaving out the decimals, and you're finally going to get to a 1. Once you stop, the fourth step is to cross out any even numbers on the left side and their corresponding number on the right. Okay, this is all going to be more clear once you see it in action and once you start doing it. And then the last step is step 5, which is to add the remaining numbers only on the right side. Okay, so divide and multiply. So let's take a look at letter A. So the way I recommend you set this up is to go ahead and rewrite this in a column, like a T-chart. Actually, let me do it this way. So, and up here on this side we're going to be dividing by 2, and the right side we're going to be multiplying by 2. Alright, so let's take a look at A. This is the chart that I recommend you do to remind you. On the left side you're going to divide, on the right side we're going to multiply. And so we're going to rewrite the numbers of our problem. Then we're going to go ahead and divide 13 by 2. And we get 6.5, which we're going to drop the 0.5 and write down the 6. On the right side, we're going to double the 23, which becomes 46. And then you don't have to go straight across. You can go straight down and then go to the right and go straight down. I'm just going to go straight across. So divide 6 by 2, you get 3. And multiply 46 times 2, you get 92. Divide 3 by 2, you get 1.5. We're going to drop the 1.5 and write a 1. And then 92 times 2 is 184. Okay? So So far, we just did steps 1 and 2, and then step 3 said to do that over and over again, in which we did, until you get to 1 on the left. And so we stop right here. Okay, so once we stop the process, now we go to step 4, which was to cross out any even numbers on the left side and their corresponding number on the right. So the only left number on the left column that is even is 6. So 6 is going to get crossed out along with its corresponding number on the right. Okay, so that is step 4. Step 5 is to add the remaining numbers on the right side. So that's 23, and then these two numbers, 92 and 184. So basically, our final answer then is going to be to add 23 plus 92 plus 184. If you add it up, you just type it in your calculator, you're going to equal the same thing we got using modern multiplication. Okay? All right. Okay, guys, so you may be asking yourself, wow, what a super long process, 5 steps just to multiply numbers when you can easily do it the modern way. Yes, that is true, and that's called the evolution of multiplying. But in this section, we are exploring ancient or previous ways how this was done. Okay, so this long process basically came from the ancient Egyptians. Okay, the stuff that was found in the Rhind papyrus. These calculations were there. Okay, ancient Egyptians, and actually it's still used today in parts of Russia, and it's called the Russian peasant method. Okay. So yeah, it's pretty interesting how this all works out, and still gets the right answer. Okay, so why don't you try letter C here and see how you do. Okay, so let me get it set up for you. So we're going to do our chart. Divide by 2 on the left, multiply 2 on the right, and rewrite our numbers here. Okay, so pause the video, go ahead and repeat the process, and add up the numbers on the right that you don't cross out, and see how you do. Okay, so if you take a look, we took 40, divided it, or halved it over and over again, divided it by 2. So it goes to 20, it goes to 10, 5, it goes to 2.5, which we dropped to 0.5, right 2, and then 1. And then 32 got doubled, 32, 64, 128, 256, 512, and 1024. Then I crossed out the 40, the 20, the 10, and the 2, since they were all evens, and I also crossed out their corresponding numbers on the right. And the only thing that was left was 256 and 1024. Those added together is 1280. You put this in your calculator, guys, and you get the same thing. Okay? So this is duplication and mediation. Alright, guys, so now we're going to go to page 4.10 in your workbook to look at another method of multiplication, which is the lattice multiplication. Okay? Now, lattice multiplication comes from the word comes from the use of a grid or a lattice when multiplying two numbers. Okay, so this is also called the Gelosi method or Galley. Basically, this method was brought to Europe in the 1200s by Fibonacci. Okay, so he's the one who popularized it. And he probably most likely learned it from the Egyptians, Arabs, or Hindus. We're not really sure. But definitely he, in his travels and his learning, he probably got it from one of these popular cultures heavily involved in mathematics. Okay, from the East. So this time period of Fibonacci was more of in the 13th century or the 1200s, and basically was very popular in the medieval times and has been used for centuries in many different cultures. It's actually still being taught today in certain curriculum around the world. I've also heard that this method is called Venetian squares or Chinese lattice. I did find a video on YouTube where a teacher, most likely in Asia, was teaching this to their elementary students, and also my daughter, who's in a Montessori school here in Winter Haven. She also, I saw her bringing this type of mathematics home as far as multiplying. So let's see what it looks like. All right, so first of all, if I'm designing my own box, let's say this is on my own piece of paper, the numbers that you write down need to be in a diagonal format. So let's say 26, we're going to write 2 up here and 6 down here. So 2 will be written in the top left and 6 in the bottom right. And then later on you can just go ahead and divide it up. Okay, so we're going to write 26 here on the side and the 37 over here on the right. And the reason why we write it on the right side is because our answer will appear on the left side. Okay, so we're going to multiply these numbers and put the products in the lattice or the box. And so we have 3 times 6 is 18. So we break it down like this. And 3 times 2 is 6. Sorry about that. And so you can put a 0 here and put a 6 here, or just leave the 0 blank, but I'd rather fill in every spot. So you do one number at a time, and then we do the 7. The 7 times the 2, 7 times the 6 is 42. And the 7 times the 2 is 14. And you may be thinking, well, there's a bunch of numbers here. What do we do all this? Well, if I was making a box on my own piece of paper, then I would cut it in half and bring down the line to the bottom. Okay, so I'm going to extend my cut through the diagonal all the way down to the bottom. Do the same thing up here. And so what we just have created is diagonals where we're going to add up the numbers in each diagonal. Okay, so we're going to be adding 2 plus, there's nothing else there, so the 2 is going to come down here. And then here we have 8 plus 4 plus 4, so that's basically 8 plus 8, which is 16. Now there's only one space for a digit, so we're going to put the 6 here, and we're going to carry the 1 into the next diagonal, And so now we have 2 plus 6, that's 8, plus another 1. So everything is being added through this diagonal. And so 2 plus 8, 2 plus 6 is 8, plus 1 is 9. Okay, and then 0, we don't need to put 0 here because it is not worth anything. That means we have no place value for that spot. So our final answer will be right here. Okay, so 962. Okay, you will have to show this type of work on the test. You cannot just type in 26 times 37 in your calculator and get 962 because you will not get any credit for that on the test. You do need to show the boxes or the lattice process. Okay, let's take a look at a 3-digit number. So you always put, it's better to put the longest amount of digits on the top and then the other one down here so that we have a nice little rectangle. Okay, so again, we just multiply each number at a time. So 2 times 5. So 2 times 5 is 10. 2 times 7 is 14. 2 times 2 times 4 is 8. And then 6 times 5 is 30. 6 times 7 is 42. And 6 times 4 is 24. Okay, it looks confusing with all the numbers there, so we do need to break this down. So this continues out here, and this diagonal goes through like that. This one like this. Okay, and then now we go ahead and add up the diagonals. So the 0 is going to come straight through. We're going to add up all this, add up all these. Okay, so 0 goes here. 2 plus 3 is 5. And then 4 plus 4 plus 4, that's 12. Plus 1 is 13. Carry the 1 into the next diagonal, which is right here. So that's now going to be 10. Okay, that's 12. And then carry the 1 in this diagonal, which 1 plus 0 is just 1. Okay, so our final answer is right here. As you can see, it's pretty interesting. And that's how you do lattice multiplication. So why don't you go ahead and try the one on the right here, the bottom right. 72 times 438 and on your own and see how you do. Okay, of course you can always start by writing the answer with your calculator and then checking to see if your lattice process works. See you in a few minutes. Okay, let's see how you did. 438 times 72 is 31,536. And this is all the boxes filled out and the rows added up. And every time you have to carry a 1 into the next diagonal. So hope you're enjoying that. Actually, this method is recommended by the National Council of Teachers of Mathematics, and just as another way to help increase conceptual understanding. And I hope that it has worked for you and that you appreciate other ways of doing things from the past and actually just being able to participate in history here. All right, well, let's move on to the third way that's taught in the textbook, and you do have to be knowledgeable on, and that is Napier's rods. So this third method was developed from the lattice method by a guy named John Napier. So let's actually go to 4.12 where it has Napier's rods. Okay, as you can see, he was a Scotsman in the 1500s, and actually, he's actually the one who came up with the theory of logarithms. Okay, from algebra 2 or pre-calculus, and so instead of coming up with, or instead of knowing your multiplication facts, this is actually using the multiples of our digits 0 through 9 and putting those multiples in a rod. Sometimes they were put in a bone or etched in a bone. So basically you have the whole system already laid out, and you just grab the rods that you needed. For example, 3 times 62. So you would write 3 on the side, and then you would grab the rod for 6's. So, oops. What did these rods look like? Basically, they were multiples of 6 in like a column. Okay. So you would have, let's say 6. Okay, so you have 0, 6, and then the next multiple of 6, so you add 6 to that is 12, then you get 18, and you have 24, and then you have 6 times 5 is 30, 36, so on and so forth, okay? 48. So that goes up to about 8. But basically, you would grab the rod, and you would grab the rod for 2. So 2 So this is some type of device or bone or something that they would write. Basically, like a little cheat sheet, okay, using these rods. So because I'm doing 3 times 62, I need the rod, the 6 rod, and the rod for the 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth, okay? And then you would just line them up, and you would say, okay, we're multiplying by 3. So basically, I'm going to see what I need to write in our lattice boxes. So 3 would be right here. Okay, so that's all this is. This is the same thing as the lattice method, except it's using these rods. And the rods are a cheat sheet, basically, and you really don't need it if you know your multiplication facts. Okay, so the 1 and 8 obviously go here, and the 0, 6 just goes here, which you can just do from your head. Okay, and then we do the same thing. So we have this deal here where you say, okay, I have 6, 8, and 1. Okay. So like I said, this is not really anything new. It's more of a adaptation that John Napier used. And this is kind of the start of the idea of this type of methodology in computing numbers that we use in modern computers, so, and programming and things like that. So very interesting what he did here, but it wasn't that much different from the lattice method. Okay, so let's just do one more quickly. So let's do 8 times 273. So So basically 8 times 2 is 16, 8 times 7 is 56, and 8 times 3 is 24. Make sure you split these up here. And our answer then is going to be 4, 8, 11, carry the 1, and that's a 2. 2,184. And I forgot to write my arrows, but you don't have to do that if you don't want. But this is where I'm getting the numbers from, okay? All right, well, that should be good enough for the homework on my math lab, and let me know if you have any questions. See you in the next video.